So proof of stake is the effort of a miner to validate and secure incoming transactions. The miner is now called validator, and is chosen in a deterministic way. So this model is based on the idea that the more stake the network user has invested into the system, the more likely they will want the system to succeed, and the less likely they will want to subvert it. So stake is often an amount of cryptocurrency that the blockchain network user has invested into the system. So once staked, the cryptocurrency is generally no longer able to be spent. So, proof of stake blockchain network uses the amount of stake as a determining factor for publishing new blocks. Thus, the likelihood of a blockchain network user publishing a new block is tied to the ratio of their stake to the overall amount of cryptocurrencies in the network. So if Steve invested 10 times more money than Dave, his chances to become a validator are 10 times higher. So with this consensus model, the network is secured and nobody can cheat. There is also no need to perform resource-intensive computations, as found in proof of work. Since this consensus model utilizes fewer resources, some blockchain networks have decided to forge a block creation reward. So these systems are designed so that all the cryptocurrency is already distributed among users, rather than new cryptocurrency being generated at a constant pace. So in such systems, the reward for block publication is then usually the earning of user paying fees for transactions. So the methods for how the blockchain network uses the amount of stake can verify. We now discuss the four most commonly used approaches. So first we have the random selection of staked users. Second, we have multi-round voting. Third, we have the coin-aging systems. And last, we have a delegate system. But regardless of which approach is used, all methods follow the rule that the amount of stake determines your chance to publish new blocks. When the choice of block publisher is random selection, the blockchain network will check the stake of everybody, and choose among them based on their ratio of stake to the overall amount of cryptocurrency staked. So if a user had 42% of the entire blockchain network stake, they would be chosen 42% of the time. And if a user had 1% of the entire blockchain network, they would be chosen 1% of the time. When the choice of block publisher is a multi-round voting system, there is added complexity. So the blockchain network will select several staked users to create proposed blocks. Then all staked users will cast a vote for a proposed block. Several rounds of voting may occur before a new block is decided upon. So this method allows all staked users to have a voice in the block selection process for every new block. When the choice of block publisher is through a coin age system, staked cryptocurrency has an age property. After a certain amount of time, the staked cryptocurrency can count towards the owning user being selected to publish the next block. So the staked cryptocurrency then has its age reset, and it cannot be used again until after the requisite time has passed. So this method allows for users with more stake to publish more blocks, but to not dominate the system, since they have a cooldown attached to every cryptocurrency coin. So older coins and larger groups of coins will increase the probability of being chosen to publish the next block. When the choice of block publisher is through a delegate system, users vote for nodes to become publishing nodes to create blocks on their behalf. So blockchain network users' voting power is tied to their stake, so the larger the stake, the more weight the vote has. Nodes who receive the most votes become publishing nodes, and can validate and publish blocks. So voting for publishing nodes is continuous. Remaining a publishing node can be quite competitive. So the threat of losing publishing node status, and therefore rewards and reputation, are constant, but in the end, it detects malicious users quickly and therefore prevents them from cheating and misbehaving. There are some flaws in the proof of stake algorithm. Rich people will get chosen more often, which means they will get more transaction fees, making them richer and therefore increase the chance of being chosen as a validator. And an even bigger problem is that validator sometimes doesn't show up to do their job. Therefore, proof of stake is a much better version than proof of work, but it still needs to be optimized and a lot of improvements.